And we're live. Hello, everyone. Welcome back to Corso Workshop live stream. Today we are in my room office on my computer, and we're live. Yeah, sound works. Thank you, Chief. Okay. Yes, we are live, and today we're going to do the part two, well, second part of the Kunai prop, which we started. Was it 2 weeks ago? Was it last week? I don't remember. A few weeks back. Hi, hey, Clever. How are you doing? So, yes, today will be 3D modeling the kunai. We'll also be 3D modeling the part that is missing for the kunai that we made with foam, but we'll also be 3D modeling a whole kunai from scratch, so that we, in the eventuality that the foam prop doesn't quite work out, we'll have something to show off, later on down the line. I am joined by Chief. Chief is with us today. Lighting seems to be okay. If we find out that lighting isn't so good, no, so far it's so good. So, so what are we going to be doing today? First of all, we're going to be 3D modeling this prop in Fusion 360, which is a program which you've seen me use in the past already. And basically, we'll be taking reference from some images which we will be finding on Google Images. Now, that is usually the place where I start, first of all, for inspiration, and also for like actual reference material. So, if I actually switch over to there we go, to my actual screen, you can see that I am currently having a look at all the images which showcase kunais from the anime Naruto. I'm trying to find like a top-down view profile, if anything, but there are some other references I can use. Starting from a top-down view, it probably would be the easiest way to start. And honestly, now that I've seen the Minato Shuriken, that is actually very interesting to make. I'm thinking we'll have to see. So, I'm thinking of perhaps, yeah, this one's pretty good. This seems to be like a photo of an actual plastic kunai. I really quite wanted to use one from the show if there is an image. Search a little bit better, find some actual reference. Hmm. I'm seeing all this information is actually quite useful, even though it's not a profile picture, like a straight on top bottom view, because it also gives me some information on how on the angles of the prop to get it as accurate as you know as I can in this case. But I know the general shape of it. Then there is one flat face on the back, split into two different faces, as you can see over here. Oh, this would be nice to make, like the throwing knife, throwing stuff. Shuriken. Oh, here we go. This doesn't seem to be like from the show. I'm sure we can start working on this, and then we can expand upon it a little bit better. The show. Hmm. I think I'm going to just get started. I just need some of these pictures, honestly, for reference and for scale, to get the proportions right. That's a good picture. Okay. No, it's not the style that I want. It's you know what? I think I'm just going to have this image there as reference and then start 3D modeling my own. So let's hop over to um over to this image to Fusion 360 over here. Save now. So this is Fusion 360. You've seen me use it in the past, and basically what I would do is go on this icon up here, which is Insert Canvas. I'm going to click on it. I'm going to navigate to my desktop, and then select on which plane I would like to paste. Have this only as reference. Not particularly fussed about it. Canvas, rotate it. Yeah. So the way to start 3D modeling anything is, first of all, you need to have some sort of reference, some sort of dimensions. Now, in my case, I think I'm going to have this much. I have a ruler here actually. Well, how much is this? I think this much is about 25 centimeters. Between 20 and 25 centimeters would be really cool for the whole thing, because I would have like a 4 centimeter loop at the back, a blade which is about 9 centimeters, 10 centimeters, 11, going up, forward. Although, like, if it is the whole 30 centimeters, quite large. Like 5 centimeter loop, have 30. Yes, I'm going to go for 30. So I'll try to start. I'm going to start by sketching some lines to give me a reference. Now, this is going to be at 300 mil, 30 centimeters, and you can see, make it a bit larger over here. I can still refer to it. Perfect. And this is my line, which is the 30 centimeters, the 30 centimeters of the whole length of the prop. Now, I already said that I wanted to have like a 5 centimeter loop, and that I can already start sketching by going into create circles and create a 2-point circle. Now, this is important because if I do by diameter, it's going to start at the point where I click. However, if I go to a circle and use a 2-point circle, I can just click on the first point, go up 50 mil, which is 5 centimeters, and there I have my first circle. Hello, Episauri Atelier. Hello, Mel. Good to have you here. I think I'm going to have like the, you know how like at the back of this loop over here, it seems to be quite thick, with the center hole being quite smaller. Now, in this case, I'm going to create a circle which is from diameter, because I already have the center of this. I think if I zoom in a little closer, perhaps I think about that looks about right. So I have a 20 millimeter gap. If I press I or go on the inspect tool and click on both circumferences, I know that I have a 15 millimeter thickness loop there, which seems to be okay. I'll create a torus, a donut later on. Now, I need to have the actual thickness of the handle. Now, the handle seems to be about the same thickness of the loop, maybe a little bit thicker. So I think we'll go for 30 millimeters, which is going to be um 30. Okay, 15 on either side. Each box is 5 mil. And how long do we want? We said that we're going to have. Okay, so 15 to 30 is going to be the actual blade itself. So if I want 15 to 30, I need a 10 centimeter. So that's 100 mil. Okay, if I press, I go over here and create a 2-point rectangle. Delete the extra lines. It's fine over here. And if I press I again to inspect, click on this point. On this, 150 mil. So that is 15 centimeters, exactly how long I want the blade to be. Now we just need to start sort of sketching the shape of the blade. Obviously, I can see from here that the point going forward is much longer than the slant back. So I'm going to sort of go for the 2/3. Actually, this looks like more of a 3/4. So 15 mil. Open the calculator. 15 divided by 4 is about 3.75. Let's do this as accurately as we can. Press L, create a line, 3.75. Oh, it's a mil, so we need 37. Okay, so that's the first line. I'm going to do another line from here to here. Just to be safe, I'm going to do 37.5 times 3. That gives me the exact 37.5 times 3. That is the exact same length. And just delete the longer line, which went through the whole prop. Okay. And how wide do we want this to be? Now, I know this is wider than the loop, so it has to come out further than, you know, um, mm, like 30. No, should be wider than this, right? Oh, yeah. Yeah, yeah. Put this over here. Just confusing me. That needs to be wider than 5 centimeters. I don't want it to be too wide. So let's go for 6 for now and see how that looks. If not, we can always increase. So, point here. Now, obviously, I'm going to be working in half. So 6 divided by 3 is by 2 is 3. Or I can do 60 mil divided by 2 over here. This 60. Just to check if I'm perpendicular, I can go on the inspect tool and check the angle between, which is perfect. Okay. Now we just need to connect the dots here, here, to here. Okay, now obviously we need to ignore the fact that there are gaps over here. We will introduce them we model this. I think this needs to be 70. So we can't just let's undo this 30. Hey, okay, so we got a few people on chat today. So first of all, hey Paul and hey Jason. Paul, this is Fusion 360. And hi Jason, good to have you here. Jason's another great cosplayer and prop maker. Local talent. Okay, so I'm going to go for 70 over here. Okay. Mm-hmm. Okay. And then we connect the lines again. Okay. Keep pressing the WASD. I've been gaming for too long recently. Alright. Okay, so I think that's good. I feel like the blade should be a little bit longer. What if we maybe seeing it in proportion? So first of all, let's move it using the move command. Feels like it should be a little longer, doesn't it? So okay. I'm going to go for this actually. I'm going to go for this. I'm going to go for this. Yeah, this is what we're doing. So let's start with the easiest stuff to make. So the easiest stuff to make would be this cylinder, the handle itself. So I'm going to select the face of the handle. Excuse me. Oh, Jason said thinner handle. We can do that. We can make it thinner with a command later on. Finish the sketch. Select that face. And I'm going to do well, function with the axis being. Oh look, something's not working immediately. Okay, let's instead. Never mind. Okay, let's do solid shapes. So in this case, let me create a cylinder. Create a cylinder on that face. We said it's going to be 30. Jason suggested a thinner handle, so let's go for 20 for now and see how that. Okay, 20 mil, and we're going to make it 100 mil long. We're just going to move it. It is in place. There. So that falls into place. Sort of as it's coming along. Right. Let's make the torus. The torus is quite easy to make. But I always say that, but then it never is easy. But this should be. Okay. Okay, so I need the. Okay, so I need a little bit of calculation. So the inner diameter of the torus is the cross section of the torus, okay? While the torus diameter is the diameter from the center to the middle of the cross section. So it needs to be a little bit smaller there and increase. Well, it's simple and isn't at the same time. Okay, so this one needs to be 15. I think I'm just at this point. Oh, that is perfect on the mark. Okay, I know that these are not aligned yet. It's going to be fine. I'm going to align everything in a second. In fact, right now, so we're going to select, go over the bodies, and I'm going to start naming just so I can easily identify. So this is the handle, loop. Okay. Okay. Just going to turn off the canvas. It's distracting me, and I'm going to turn off the sketch. Now, this I'm going to have to move it by clicking the object and pressing the move or pressing M. I'm going to sort of move it up towards the middle. Now, as you may notice, this obviously is thicker with torus, which might be a problem, but I think I can solve it. So the way I'm going to solve it is I'm going to extrude this. Extrusion meaning I'm going to pull it further out. So I'm going to select that face and press E, okay, for extrusion. And I'm going to move it further in. So I'm going to move it over here like so. Now you notice that this is sort of biting out and it has an operation which is join. So if I press OK, this has become one thing. Now I don't want that yet. What I'm going to do is I'm going to go one step forward and go back down here. Down here I have my timeline. Now here it can show you like every step that I took in the making of this object, or I can go back and rewind time. I can double click on the operation itself, and instead of join, we'll do a new body. So now this piece has become this piece of cylinder is its own body number 3 over here, as you can see in the bodies. Now I need this because at the moment I think the best thing to do is take this rim over here, the edge of this cylinder. I'm going to flatten it slightly into a more conical shape using the chamfer. We're going on modify. Selecting the chamfer tool, and I'm going to start with a 1 centimeter, that 1 millimeter doesn't quite cut it. Perhaps 2, 3. Let's do 3.5, and now I can see that the whole rim of the cylinder is sort of buried into that torus. At this point, I can start um, merging everything together. The thing is this: first of all, the handle and that piece can be together. That's fine. So I can just click combine over here, combine them using the join operation, and now that has become one thing. Okay, one. Thing is this: I don't want to print this whole handle as one thing. For example, I'm going to be 3D printing it. The problem will be that I printing circular rounded stuff on a flat bed, on a flat printer. Okay, obviously it's going to have its own challenges because FDM printers like the one I have over here, I'm currently using as a paper holder. Don't judge me. It's going to start melting plastic and laying it down, and often until that plastic melts, until unless you have an excellently set up cooling for every layer, is going to droop slightly. And as probably Jason can tell you as well on chat because he's an avid 3D printer as well, um, it's going to have a flattened bottom, and that is not something that I want. So probably what I'll be doing is I'm going to have a flat face on the loop, um, so that I can print it from that flat face going up. Okay, and we'll have to see how that works out. But for now, we're just going to continue following our sketch. Now, this is the tricky part because this is an item which requires a little bit of thinking about. So, what I'm going to do is I'm going to make my life a tiny bit easier. So, I'm going to take the handle and the loop together by pressing Control and clicking them, or no, actually, that's the best way to do it. Just Control and click them, pressing M for move function. Move them, and I'm going to move them so that they are halfway down through my sketch. Now, this allows me to create one side, the top side of this model, and then mirror it later on down the line without having to repeat all my steps. Now, I'm going to take this part and this because I don't need it anymore. It's just interfering with my sketch. Okay. We're going to use the design which we have on this, which is 4 facets on the Kunai. I think I want the Kunai to be as high as it is wide. I think we can start from there. Then we can work on flattening it a little bit later. So I'm going to start by selecting one of the portions, pressing the E to extrude, and actually pressing it to see how long this is. We made it 35 mil from one side to the next. Okay, so extrude this to 35 mil and unhide. And this is a little bit too much. Now, I think what I want is of this because 35 is like from the bottom layer to the top layer. So what I'm going to do is go back to this extrude function and do divide by 2. Okay. Now I'm going to repeat the same step over here. 35 divided by 2 and just go 17.5. And I'm going to select new body every time. And also just press E, select this face, and it automatically brings it up without having to remember numbers or set up information. Body. Okay, so there we have the first crude shape. Now, I think we can probably get away with chamfering alone at the moment. So if we go to modify and chamfer, I don't think we'll need an equal distance. I think we would need to go at a much steeper angle, but let's see what an equal distance will give us. So at 15 it gets us over there, and that's not quite right. So probably to distance and angle. Leaving a little bit of a lip. It's fine. We can work around it. So we did 25 on one and 15 on the other, and that gave us that angle. Same thing over here. Chamfer side, two distance 25 and 15. Okay. Now these two we're going to chamfer simultaneously because we're going to have the same. So maybe 32.5. Not perfect. I think there are some discrepancies in the angles over here, as you can see, which is a little bit weird because this side they fit just fine. But that gives me an idea. Okay, so these are all four individual bodies, right? And I think this looks okay. Let me select these two, and it highlights the ones that to select. So just right click, remove, and I'm left with half of it, which is fine. I'm just going to take these two bodies, which are the blade, combine them together, and combine function join. Okay. Now this I would rather have it come to a point. So maybe with a pull function. No, it's not. That's not. That's with it. It's tiny. It's probably not going to be showing on the 3D print. Um, if I take this and call it blade, I can go into create, mirror, select bodies. I'm going to be mirroring the whole body. Select the mirror plane. It can be like a central axis on the XYZ, or it can be one of the faces of our own model. And there we have mirror. So we have the blade there. Now we noticed that earlier I said that there's a little bit of a lip. What I can do is I can inspect the distance, which is 2.5 mil. I can go on this face, press E to extrude, and do negative 2.5. But this is also going to be cutting out of the cylinder because of the way it works. So I'm just going to undo that. I'm going to hide the handle, and I'm going to do this minus 2.5. Okay. There's this weird gap for some reason. It's like we had an issue with our sketch. So let's fix that because it's going to cause problems. But it's a symmetrical piece that comes to the point. So the way we can fix that is by going into the sketch over here. And probably over here somewhere there is this 90.9. Aha, so this was the issue. So probably this somehow messing it up worse. Hmm. Trying to sort of understand this. How come it, how it came to okay. This, this is the point that needs to move down, I think. And not whoops. It's moving the whole thing. Like it's angling because it is um, 90, we go to 70, which was initial. Let's see if okay, yeah, okay, it's fine. So we just messed up a little bit. Now these yellow ones mean they have issues, so we can wind them, and this is so we're just going to have to rewind a little bit. This is fine. Okay, so go down here to the timeline. Timeline that's low key references. We're literally going to be erasing. So right click and delete all features after history marker. Just going to have to redo this. Move the handle. 1, 2, 3, 4. Let's do it once. Time we said 5 divided by 2, 5. New body. That one with body. That one with find item. I think it's and then we just need to rechamfer everything. Should give us.
It's just said that.
Yeah. Okay. So what if this we do 20? Okay, so 18. No. 15 seems to be the. Let's go 15 because that's okay. And then we'll chamfer these two edges like we did earlier. I think we still need to go down 15, but we need to go further in. Okay, I'm just zooming in to see. 32 too much. 32.5 won't work. 32 so 33. 9.8. 32.9. It's still asymmetrical for some reason. So you can see that there's this gap and it's not equal on either side. Somewhat annoying. Okay. There probably is a better way to do this. Just wait. No. Ah, what if I inspect this edge? So small, it's not even registering as a distance. Okay, what if I combine this? It's so small, it's not even registering as a distance. So we'll just leave it as is. Okay. Now let's inspect this again. I believe it was 2.5. Yes, 2.5. Extrude minus 2.5. That's there, and we're also going to be showing. I'm going to get showing the handle, moving this a little bit more centered. Select the body, move. Actually, I need to move it down by 2.5 minus 2.5, which is the distance that we have cut out and extruded. And so far, it's be looking quite fine. So let's have a look at the episode where you're reminding everyone to hydrate. Very good. I think we should put that on a t-shirt for you. Can you define the dimensions triangle you have created at the top? Yes, actually, we don't have to sketch freehand, so to speak. You can give it dimensions. You can create a triangle by going. If I'm creating a new sketch, you can go into create polygon. And for example, you can select between a circumscribed and an inscribed polygon. Let's go for an inscribed. You can define the number of edges. 3 in this case would be a triangle, and then you can define, um, you know, the the distance from the center of the circle to the outside. Okay, so it's basically from the center of the triangle to the edge. Okay, back and delete. Okay, so we're just going to take this blade and create, mirror it using this mirror plane. I'm just going to do a new body for now. Why? Because otherwise it will merge everything with the cylinder, and I don't want that. I'm going to take the last two bodies that I have created, which are called blade on its own, and combine them. Okay, joining them together. I'm going to be doing the same thing for this cylinder as I did earlier. I think in this case, I'm just going to transfer it right here. It will mess up. Just transfer an equal distance for 5 mil. Okay. Okay, but I'm going to move it a little bit further in. I'm going to move them a little bit further in so that there's a little bit more grip. Okay. Okay. I think that is decent. This blade. Okay. So here's the thing. I can't take them individually and start 3D printing them because obviously they will not fit in together the way that I want, because the handle itself is still a cylinder with two chamfers on either side. So it doesn't have any space for the blade to go in. Cheers, kid. So what can we do in this case? Well, there are two things. We can either merge this together and then slice it up into three different pieces, for example, or two different pieces, and glue it together, which is one option that I will do as well. In fact, I'm going to do it right now. But before we do that, I'm going to create a new group, and I'm going to call this the original pieces. Okay, take these three, put them in there, and then copy them. But I'm going to copy them slightly further. Control C and Control V, copy and paste shortcuts, and I'm going to just hide the first one. Now these are the ones I'm going to be tinkering around with. I'm just going to select all these, combining them together and creating whole kunai. Okay, so now whenever I move something, if I take this object and move it about, it's going to move as one whole piece. Now I have to do I have to keep in mind some things when trying to 3D print. As I said, an FDM printer, or even SLA technically, but I have an FDM printer, the proofs are back here. Um, hmm? Oh, definitely. Yes, definitely. We have to print it upright. In fact, that's what I was going to get. However, there are still some issues there. So the printer goes from bottom to top. So it prints the bottom layer first, obviously, and then goes up. And the resolution is not in the X, Y direction, okay, but the best resolution is in the Z axis, which is up and down. So if I want to have more details, I make sure that those details are on the upright faces, because stepper motors on these 3D printers are very fine devices, and they can go up an infinitesimal amount as much as you need. So you can have a very, very detailed face. However, the XY resolution is always dependent on the thickness of your nozzle, which in my case is a 0.4 millimeter. So no matter how much detail I have, if it's smaller than 0.4 millimeters, it risks to either get deformed or not visible at all. Okay, or a multiple of them. So that's one thing. Now, Jason rightly suggested to print upright. That is a great idea. However, one thing to keep in mind is that if you print something like this upright, the vertical layers, because one layer is stacking on top of each other, that is the weakest point of the 3D print. Okay, because the layers can laminate, and that is where they break most of the time. They won't break on the XY direction, they will mostly break on the Z direction. Now, given that this is a prop, it's not going to be handled or thrown or that sort of thing, it probably is just fine to have something like this. Okay? Another thing to keep in mind with regards to the Z layers, to the layers which go on top of each other, is how much post processing work do I want to put in? Is this something that's going to take me 15 hours to print so that I don't have to send it as much? Or is this something that I can get away with having a little bit of a rough layer? And that kind of brings me to the last point that I would like to make is what is this prop going to look like in the end? Now, I know that for sure the front part is going to be metallic, as is the loop, but the loop is black, as we can see on the canvas. Okay, the whole thing is black, but the loop at the back doesn't seem to be like as metallic or glossy as the other part. So the other parts are probably going to get a chrome finish, and then probably, I'm not sure. Um, I'm going to mask some of it and maybe have black on it. Seems to be like a darkish black. I don't want it to be like mirror finish chrome, maybe like a gunmetal. We'll see what paints I have. But the loop can just be sprayed a black metallic color. This is the thing though, the handle doesn't need to be painted at all. I'm just going to give it a coat just for completeness, but I'm not even going to sand it because I'm going to be wrapping it into like this sort of fabric. So that is one thing that I'm going to have to keep in mind. So it doesn't make sense for me, for example, to split this piece down the sort of the middle of the handle. So if I go over here to modify and go into split body, okay, I can select the splitting tool. So let's start with drawing a line first of all. If I split it right here, I'm going to have one print on this side and one print on this side, which is fine. Honestly, you can print it. You just need to make sure that there's enough support over here. Hold it up, but that's going to be the issue anyway, whether it's cut here, or wherever. However, this doesn't need to be the same resolution as, say, the torus over here or the blade over here, because these need to be extended to a nice level. So what I'm going to do is I'm going to move this close enough over here and create another, say, somewhere around here, roughly. Okay, as long as it is perpendicular to the prop. Move it a little bit over here. Now I'm going to split it into three. So sketch. Okay. First one, I'm going to go split body. Select the body and select the splitting tool. One, two, to show me it will on this axis. Okay, okay. Cut them into three. So this will say blade. This is here. This is handle, and this is loop. Now, if I take them and rotate them 90 degrees, so you can see exactly the orientation at which they will print. Excuse me. I'm getting confused. Okay. We'll align everything. Okay. Here's a little trick for Fusion 360. If you go into modify and line, you can select center point over there, center point over there. Sorry, not center. We need to select the face. Align. Face to face. And align. Face. I'll just move everything together so we can play there so you can see. So this is the orientation in which I would print them. Okay. Probably these two, the blade and the loop, will be with the same print height, same print resolution, so that they'll be quite nice. Let's say 0.06 mil, for example, between every each layer height. This can go by, I don't know, point like 0.3 mil, zero point 0.4, depends on the printer, but like a very rough quality, because that's going to get going to okay, yeah, it's not going to show. Another thing to do is I could add a little bit of structural integrity and a little bit of weight to it by inserting like a threaded rod or a steel rod or something in the middle. Now I know that I have a 10 mil threaded rod, so I can just go this part, press C, actually just sketch, the top of this, press C for circle, and go on by 10 mil. Okay, I'm going to give it a little bit of what do you call it? Tolerance. Let's say tolerance is going to be 0.5. Okay, so 10.5. Select that circle, press E, and extrude all the way down, which is basically hollowing it. Okay, that 0.5 allows for a little bit of like, what do you call it? Like when the 3D print cools a little bit, can expand a little bit, it allows for a little bit of tolerance. It's good practice. I'm going to mirror this on either side, but not obviously not the whole way through. So let's start with the loop. That is easy. See, center 10.5. Okay. Now, how far in do I want to go? Not too far. So, like for example, if I do it till here, it's not going to overlap on any of the borders. Do this. Okay. And it seems to be. And let's do the last thing right here. Sketch that. See, there 10.5. And again, I'm going to select the circle and extrude. Now, for the blade, I can extrude much higher into the blade. Okay. And let's go. Perfect. I can see that there are no holes on the faces. That goes in quite a distance. Now, let's see how I need to take note of how much the threaded rod I need. So I know that this is 7 centimeters. This, the height of this is 90, so 16, and finally I'm going to measure from this face to this face, and that's another 9 mil. So yeah, I have. Perfect. Definitely we can do that, and it was something that I thought of. However, here's the thing: 3D printed material is durable, but it is at the end of the day it is quite brittle. PLA is quite brittle. So if I pass a threaded rod through it, like a steel rod, I'm going to give it the rigidity of a steel rod. Um, so that I think will give it a little bit more durability. But yes, you can definitely extrude another piece sort of to interlock into it. Yes, definitely, of course. As long as you take into account the tolerance considerations, you'll be fine. I'm trying to think whether I have a prop which was built that way. I can't think of any right now. But yes, I mean, it's a common enough technique, at least even on other prop makers. Thanks. Thanks. Cool. Okay. So, trying to think whether it needs anything else. Let's have another look at the reference material. Yeah, it's right. The rod will give it a bit of a weight as well. When a prop is heavy, it feels really good. Yeah, this is the gun that you've got me is a prop. Obviously, it's all plastic. Has some dust on it, but basically, this is a German World War II gun replica. Um, and obviously it doesn't function. It's plastic. Just has some moving parts. That's all. But when I 3D printed this I 3D printed it as a whole piece, as a solid block of plastic. and the weight that it has, even though it's still plastic, it's so nice. Um, makes the prop feel very real, and that is in fact what I want to accomplish with this kunai as well. Like if I were a ninja, if I were Naruto, I had this kunai, and were to throw it, would have some heft, right? Um, so yeah, definitely, this is the way to go, and I think it will also be top heavy towards the blade because it's going to have more steel rod going into the blade than it has on the handle and in the loop. So obviously, throwing a knife would usually be top heavy, at least from my recent experience with throwing. Okay, so the last thing left to do is to um, export. First of all, let's save and call it Kunai. I think I will make these STLs available either to Thingiverse, my mini factory, or I'll see if it is possible to put them on Corso Workshop. There's a lot of light. I'm whiting out. Yeah, so if we go on tools and click on the 3D print or make, okay, and click on the body that you have over here, and you can either select Cura directly or whatever kind of slicing software you'd like to use, or just untick this box and just save it. Okay, let's save it to desktop for now. And blade one, so handle, do the same thing. We're going to save it, and we're going to save the loop thing. Now, if we go over here and open one of them, going to open Cura, which is slicing software. Now, for those of you who are not familiar with 3D printers, a slicing software is basically the translation software between this 3D model onto the printer's instructions. It basically translates this 3D model to a set of Cartesian coordinates, which are the XYZ, okay? Cartesian coordinates, for the printer to tell it exactly where it needs to deposit the filament and by how. And 3D printers usually use, in my case at least, the 3D printer does not use filament. Right. I show you what a filament looks like. Stuck behind the television. This filament, okay? It's basically just a spool of plastic. Really, this is PLA, polylactic acid, which is the easiest kind of material that you can use for this sort of application. ABS, I can't spell the full acronym, acrylbutadiene something. Um, and nylon, you can print with nylon, you can print with other materials as well. So we're almost done, I think. Once we slide it, I think we can call it a day. Now, there are a few things while we're here, and it's a little bit early. It's only five. Didn't have a very long session today, but while we're here, let's give a little bit of a rundown on what makes a 3D print. Now, first of all, there are certain things you need to consider. Obviously, may seem like a lot, and usually would have a simple print setting interface. I usually like to control every, like something like this you would start off. I prefer the custom because I can control every different parameter into settings that I know that my printer will use. So, translate properly. So by selecting the body, I can rotate it to make it print upright. Okay, so that is how it will print. Now, if I go if I leave everything as is and click slice, I can go on the preview and I can see like layer by layer how it is going to be built. Now you can see that on the inside it has like this crisscross pattern. I don't quite like that. We're going to fix it. Okay, so this is how it's going to be. It's going to start from the lowest layer, which is going to be donut shape, and build one layer on top of another. Okay, and you can also see in which order is going to build the, the layer. It's like a bit of a playback on how it's going to build it. Now the green lines are shells, like inner shells, and the red lines are outer shells, while the orange lines are infills, which give it structure integrity. Because as you can assume, it's not going to be a whole um, chunk of plastic this time. I don't, otherwise, if I were to set it to 100% infill, and I slice it with the current settings that I have, which are normal settings, and I want finer settings, mind you, I want something like extra fine setting for slice. It would take on roughly 1 day and 11 hours, well, 1 day, 12 hours, would use about 20 meters of material, which is a little bit insane, um, just to have a solid piece of plastic, which isn't the point of having a 3D printer at all. You need a solid piece of plastic, just learn and get it injection molded or cast it in resin. No, no, for me, I'm going to go for 20% infill. That gives it quite a bit of structural integrity. And for the infill pattern, I'm going to go for gyroid. Now, gyroid is this really cool infill. It's like an undulating like waves which crisscross over each other. I'm going to show it to you in just a second. But mesmerizing to look at. It still will take 7 hours and 53 minutes, or roughly 8 hours, but that's nowhere near the time which we would have used there. So, the gyroid infill, you can see over here is this like crisscrossing wave. And this imparts like so much structural integrity. Like I've seen cubes made out of like this pattern, and like a small 10 by 10 cube can take the whole weight of a human body, which is insane. Um, so I'm going definitely for gyroid. So this is going to take 8 minutes. I'm going to also have the adhesion type, which is this cyan circle over here. The aim of this is to help the prop stay stuck to the printer, because due to temperature fluctuations and fall off, etc., etc. So we have different ways to do it. You can have none and risk it, honestly, or you can go for example, you can go for something like a skirt, which is um, which is like a small ring around the prop, sort of keep the heat in. I prefer in these applications to have a brim. I'll show you what a brim looks like. So this is the skirt. It's going to be 3 layers wide, or you can have a brim which is a little bit wider. You don't have to slice it every time. Okay. Okay, so this is the brim. So when it's going to print, the first layer is going to be this brim and the inner outer layers, and obviously the bottom is going to be a hole. Okay. So that is going to be printed this. Okay, makes sense. So everything looks good. Doesn't seem to have like any issues so far. Printing like a solid mass, no gaps. I can see at least. I mean, it does. I think it may have some issues over here, but it's not like I'm going to have any holes. I think this will be now 210 degrees and 65 degrees. These are the temperature for the nozzle for the plastic to melt, and the build plate temperature, because some 3D printers have a heated bed like mine, and they keep the the print adhered to them. Okay, helps with printing. Now the last item I'd like to talk about is the support. Now let's say, for example, we are copying this, and let's multiply it, and this one instead is going to be tilted. This way I can print in any orientation I want. You'll notice that this face over here has turned red. That means that with the current um, settings that I have for support, um, this is not going to be supported at all. In fact, if you notice, if I were to tilt this even further, like that, like this, for example, Notice that the whole bottom is red. Now, why does that matter, especially here? Now, obviously, like anything else on the world, 3D printers have to follow the laws of gravity. Now, if I try to print the bottom, that's fine. If I try to print this part over here, I go to slice it, you're going to see the preview just a second. It's quite interesting. You're going to see that there is this piece over here. Just a second. See this piece over here, which is going to be printed up in the air. See over here? The printer is going to try and print this piece without it being joined to this piece first and without anything supporting it underneath. And that obviously will result in a failed print. So what do we do in that case? In that case, we create supports. And the supports, there are different support structures. Let's go for normal. We're going to go for an overhang angle of 50 degrees or higher. So anything which is tilted by 50 degrees or higher will get a support structure underneath them. And in this case, I'm just going to go for and if I slice this again, the preview, once it renders, you will see that it will create a structure underneath it to support it. And so far I just did anything touching build plate. So if there are any internal overhangs, which is what we call these structures, like structures hanging out over the air, they're called overhangs. If there are any on the inside, it will ignore them. It will only go for the ones on the build plate. Okay. You can see you've got a bunch of cyan structures. Okay. We'll keep on building them, and then once it gets to this point, you'll notice that this piece would have been built on top of a layer of supports. Okay, and on the inside it did not build any because we said we're only going to put supports on the ones touching the build plate. Now, why don't I do it like this? Why don't I lay it flat? Well, these supports tend to leave a bit of a rough texture after you remove them, so then there's a lot of sanding involved, which would sort of defeat the purpose of having such a fine layer printing 0.06 of a millimeter. So yeah, definitely. This obviously won't be printing it this way. We're not going to have any supports. We're just going to turn them off. And if you notice over here, um, you see that there is the hole which we said we're going to put the threaded rods through. And this can obviously suffer from the same problems because it is an overhang. It's a flat piece hanging down over anything. But the printer is able to bridge a little bit like between 2 points. And I'll show you one last thing. Show you how it does it. A little bit. Go up a few layers until there we go. It's about layer 1170. Now if I go over here, so this is how it's going to print it. Okay, I'm going to do the infill first, then it's going to do the inner ring and start bridging. Okay, so the printer is able to bridge between one point to the next as long as it is not too far off, because then you'll have drooping of the layers. I may still have some drooping over here because the printer will be going so slow, but since it's on the internal part of the prop, it's not going to show. I'm not too worried about it, and I can always knock it off with the threaded rod itself. That's not really an issue that I am concerned. So I think that just covers like the whole point of like my process for 3D printing props, honestly, from scratch. All that's left is to 3D print this. Okay, so let's have a look. So this one is about 7 hours and 55 minutes because of the gyroid infill and the brim. So let's just save this to disk. Stop. Let's use the same settings. Just remove this and open. Uh, take the loop and here we're going to do the same thing. This may need some support because it is a little bit sharp. Okay, we're just going to put support everywhere instead of just touching the blade. Everywhere. Slice this with the same settings that we had for the blade. So this is going to be the same resolution. Will it have some problems of like texture on the inside and down here where there is an overhang? Yes, but I mean, sanding this as opposed to sanding the whole piece. This will take 3 hours and 37 minutes. So we're up to what so far? 10 hours, 12 hours roughly. Save this. And we're going to print the handle at a much lower resolution. This like that. Remove supports. We're going to leave the brim because it's a bit of a tall structure. Instead of extra fine, we're going to go for we can even go for extra fast to be honest. Changes. We're still going to have a gyroid infill though because I want that strength. Okay. And this will take about 51 minutes, and that is the difference in speed between qualities. Okay. Everything is still infilled at 20%. So it is 20% full. Okay, and that is okay. I think honestly that was like all of it. That's all the process to make something like this. Normal colors. So yeah, honestly, that is how I would go about 3D modeling and using this technology, okay, to make these 3D printed props. And I think it came. I think it will look quite nice. Um, I may do multiple of these. See if I can give them out. I think that would be cool. So yeah, I think we're up to date also with the chat itself. Um, got the chat right over here. Got Chief back here looking at the chat as well. So yeah. Okay. For some reason, my chat is a little bit more delayed than yours. Yeah, thanks, Paul. Thanks for joining today. Um, oh yeah, cool. All right, so I think that just covers the process. I think we're going to wrap it up here today. It was a short, like 1 hour, 20 minutes kind of live stream. I think how long have we been going on? Go for 1 hour 20 minutes. Okay, so oh, why is my chat so slow? Oh, I mean, if you have learned something from this, I'm honestly impressed, man. Because Jason is a pro at 3D printing. I mean, comes to 3D printer. I'm making 3D models soon, and this was helpful. I'm so glad to hear that this was helpful for a bunch of people. No, I mean, if you have any questions on this process, just let me know. Either leave them in the comments after this goes live, or just reach out to me on Instagram or Facebook. I'm more than willing to help. So yeah, you can always. Yeah, I'm always ready to help if you guys need anything. So just let me know. It's cool to share this skill with a bunch of people. It's just a cool skill. Um, I think we can wrap things up, don't you think, Chief? Yeah, wrap things up. Thank you very much for joining us for the Corso workshop live stream today. I hope this was useful to you and was entertaining a little bit. This was certainly interesting for me. So yeah, for once, things went off without a hitch for the most part. So tune in next week for the next live stream. I'm still working on the next video. The next project video is going to be interesting, and for those of you Witcher fans, I think you'll be delighted. So yeah, especially the Witcher folk friends of mine. That would be interesting project. Keep an eye out on Facebook and Instagram because later on tonight and tomorrow and in the coming days we'll have some exciting news for all new geeky nerds out there who like all sorts of geeky stuff. It's going to be a new project between myself, a bunch of other friends, some of which are on the chat right now, and I think it will be worth. So, thank you very much for joining us. Thank you very much for commenting, chatting. Thanks to everyone. Melissa, Paul, Clever, and Jason for commenting. This was quite interesting to have. It was quite nice to have you guys over here with me today. And I hope you have a good Sunday evening or a good Sunday if you're on the other side of the world. And I hope you have a nice rest of the weekend. Take care and keep safe and keep making stuff because honestly, this is just so awesome. Yeah. Anything to add, Chief? Oh, cool. Oh, cool. Thank you very much for joining. Have a nice day, and I'll catch you next. Take care.